Welcome children, take up your geography book. Chapter 3 Weather and Climate. Today's topic is rain gauge. Rainfall is the most common form of precipitation. Now the most common form of precipitation is the rainfall. Rain gauge measures the amount of rainfall received in that area. Now the instrument used for measuring the rainfall in the area, it is the rain gauge. It consists of a metallic cylinder or jar with a vessel placed inside. Now rain gauge, what does it consist of? It consists of a metallic cylinder, or you can say a jar with a vessel placed inside. The funnel is set on the top of the jar that fits accurately. Now a funnel is set on this top of the jar and it gets fit accurately. Rainwater is collected in the vessel through the funnel, and the rainwater it gets collected in the vessel through the funnel. This water is then poured to a measuring jar that is graduated in millimeters or centimeter. Now, this water it is then poured to a measuring jar and that is graduated, that is calculated in millimeters or in centimeter. The reading is taken at an interval of 24 hours and each reading is taken at an interval of 24 hours. The rain gauge is placed in an open area away from trees and buildings. Now rain gauge, where it is placed? It is placed in the open area which is far away from the trees and buildings. This is also done to ensure that splashes of water do not cause the rain gauge to collect extra water. Now why it is done? It is done so that the splashes of water do not enter the rain gauge to collect the extra water. The apparatus is placed below the ground so that only 30 centimeter of it remains above the ground. Now this apparatus it is placed near about 30 centimeter below the ground so that it remains above the ground. This prevents splashing and evaporation of water collected in the jar. And what it helps? It helps to prevent the splashing and evaporation of water which are collected in the jar. Snow, hail and sleet are also measured with the help of rain. Now snow, hail and sleet, these are also the forms of precipitation. They are also measured with the help of rain gauge. But these are melted before the measurement is taken. Barometer. The year in the temperature has weight and thus it exerts pressure on the earth's surface. Now year in the atmosphere, it consists of weight and even exerts pressure on the earth's surface. At sea level, a column of air exerts the pressure of little more than 1 kg per square kilometer. At little level, a column of air which exerts the pressure of the little more, that is 1 kg per square centimeter, which is shown with the mercury column of 70. Now it is shown as a mercury column of about 76 meter. Now atmospheric pressure is calculated in here. Now how is atmospheric pressure calculated? Now atmospheric pressure it is calculated in millibar. Now atmospheric pressure it is calculated in millibar, that is at the sea level it is approximately 10.13 millibars. Now at sea level this is approximately 10.13 millibar. The atmospheric pressure is the highest at the lowest altitude of the atmospheric pressure. It is highest at the lowest altitude of the earth. As we go above the earth's surface, the pressure. Now when we go above, what happens? When we go above the earth's surface, what happens? The pressure decreases. Barometer is a device to measure the atmospheric pressure. Now what is barometer? It is a device which is used to measure the atmospheric pressure of a place. Since the atmospheric pressure changes with the distance above or below the sea level. Now as the atmospheric pressure changes with the distance which is above or below the sea level, the device is also used to measure altitude. Now this device it is even used to measure the altitude. There are two main types of barometer. Now barometers are of two types. One is mercury barometer and the other is aneroid barometer. Mercury barometer constitutes the mercury filled glass tube. Now mercury barometer, it consists of mercury filled glass tube more than 76 centimeter long, sealed at one end and inverted in a ball of mercury whose surface is exposed to the air. Now it is more than 60 centimeter long. It is at one part it is sealed and interval and inverted in a ball of mercury, and this surface it is exposed to the air. The mercury in the tube moves up and down until the pressure of the atmosphere is balanced by the pressure at that point. Now, mercury in the tube, what it does? It always moves up and down until the pressure of the atmosphere gets balanced by the pressure at the point where the tube intersects what happens? It intersects the surface of the mercury in the container and creates a vacuum on the top. This gives the atmospheric pressure which can be read on a scale calibrated on the glass. This, how can it be read? It can be read on the scale which is calibrated on the glass tube. With an increase in the atmospheric pressure, when it increases, the atmospheric pressure gets increased, the mercury in the barometer, what happens? It rises, and on the other hand, with the decrease in atmospheric pressure, the level of the mercury drops. Now, on the other hand, what happens? When there is a decrease in the atmospheric pressure, the level of the mercury drops. Android barometer is an easily portable instrument used for measuring air pressure. Now, Android barometer, what is? It is an easily portable instrument which is used for measuring air pressure. It resembles a small pocket watch and it does not contain it. Now, what is shown? It looks like a small pocket watch and it does not contain any liquid. It is used by the explorers and travelers. Now, who uses it? It is used by the explorers and travelers. Wet and dry bulb thermometer. Humidity is measured by a wet and dry bulb thermometer or hygrometer. Now, humidity, what it is measured by? It is measured by wet and dry bulb thermometer, or it is also called a hygrometer. One of the bulbs is kept wet in distilled water. One of the bulb, it is kept wet in the distilled water, and the other bulb is kept dry. The rate of cooling or the wet bulb is proportional to the rate of evaporation of water. Now, rate of the cooling of this wet bulb thermometer, it is proportional to the rate of evaporation of water, which in turn depends on the relative humidity of the air, and in turn it depends on the relative humidity of the air. When the air is dry, evaporation is rapid. And now, when the air is wet, what happens? Evaporation, it is too fast. And the wet bulb thermometer shows what it shows? It shows a very low reading. The difference in temperature between the two thermometer indicates humidity on a scale already provided. Now, difference in temperature which is in between the two thermometer, it indicates the humidity on the scale that is already provided. When the humidity is high, fog or clouds can form. Now, when the humidity is high, what happens? Fog or clouds can also be formed. A low relative humidity is indicated when there is large difference between the readings of two thermometers. Now, a low relative humidity, when it is indicated when there is large difference between the readings of the two thermometers. Conversely, a small difference means really high relative. Conversely, small difference, what does it mean? It means a high relative humidity. Wind vane and anemometer. Now, wind vane is a simple instrument used to determine the direction of. Now, wind vane is what? It is a simple instrument and it is used to determine the direction of the wind. It should be placed in open area where the wind is not blocked by buildings. Now, where it should be placed? It should be placed in open area where the wind is not blocked by the buildings or the tree. A wind vane consists of two parts. Now, wind vane, what does it consist of? It consists of two parts, that is a pointer mounted on the pole that moves freely and points to the direction from which the wind is blowing. The pointer, which is fixed on a pole and it moves freely on points to the direction from which the wind is blowing. A fixed marker showing the cardinal direction, namely north, south, east and west, which has to determine the direction. Now, a fixed marker is there. It shows the cardinal direction. The cardinal directions are north, south, east and west, which has to determine the direction. Now, this direction, it has to determine the direction of the wind. Winds named after the direction from which they blow. Now, winds, how they are named? They are dependent. They are named after the direction from which they blow. For example, wind blowing from the west are called the westerly. Now, for example, winds which blow from the west direction, they are called the westerly wind. The speed of wind is measured by anemometer. Now, anemometer is used to measure the speed of wind. It has 4 semicircular curves. Now, anemometer, it consists of 4 semicircular curves that are fixed to a rotating shaft. Now, these semicircular curves, they are fixed to a rotating curve with the help of the thin rod. The movement of wind causes the cup to spin. The movement of wind, it causes the cup to spin. The inward curve of the cup receives the maximum force. Now, inward curve of the cup, it receives the maximum force of the wind. A meter attached at the base records the number of spins and measures the speed of wind. Now, meter which is attacked by the base, it records the number of spins and even measures the speed of wind, that is in kilometer per hour. Isotherm and isohead. Now, isotherms and isohead. Isotherms and isohead represent temperature and rainfall patterns on a map. Now, isotherms and isohead, what it represents? It represents the temperature and even the rainfall pattern on the map. Isotherm are lines joining places having equal. Isotherms are what? They are the lines which joins the places having the equal temperature. The word isotherm is derived from iso, meaning same. Now, what isotherm? From where it is derived? It is derived from the iso. The word iso, it means same. Therm meaning heat and therm means heat. Isothermal mass shows the distribution of temperature over the area. Now, isothermal, it is used to show that the distribution of map covered over an area. Isotherms are made by taking the temperature recorded at different meteorological stations on regional or global scale. Now, isotherm they are taken by the temperature recorded at the different meteorological station or as regional or a global scale. Isotherm help us to predict the weather of the next year. Now, isotherm, what it helps? It helps to predict the weather of the next few days. The rainfall data collected by the meteorological station is plotted as isohead. Now, meteorological data which are collected by the meteorological station, they can be plotted by as an isoheads on a map to understand the distribution pattern. It helps to understand the distribution pattern. Isoheads are imaginary lines. Now, what are isoheads? These are the imaginary lines joining places with the same amount of rainfall. Now, isohead joins places with the same amount of rainfall over a unit of time. These are drawn at uniform intervals. Now, these are drawn how? They are drawn at uniform intervals on map. Rainfall is also depicted on map to show seasonal distribution and variation across region. Now, rainfall is also depicted on the map and this shows the seasonal distribution and even the variation across the region. Now, revise this chapter again in diary, right? Chapter 3 completed, explained in class. Revise the chapter again and again, and with this I am ending my today's class. Goodbye.